Hello, you lot. Right, just going to go through these structural isomers questions. It's Sunday night and I'm going to do a few of them. I'll get a few of these uploaded and maybe try some more tomorrow morning. Right, we're dealing with structural isomers. Isomerization. There are two types of isomerization that we looked at in the exam, structural and stereo. Struct and stereo. There are three types of structural: chain, position, and functional group. Okay, so that's what we've done so far. How many structural isomers with an unbranched carbon chain have the molecular formula C4H8Br2? So this unbranched means C, 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 C. So I've got to work out how many different versions of this you can have. Well, you can have Br there, 1, 2, 3, 4. Br here, Br there. You can have 1, 2, 3, 4. Br here, Br there. You can have 1, 2, 3, 4. Br there. Br there, so that's 1, 2, 3, 4, and then you can have Br there, so that's 5, and any others you could have, the middle two. Br there. I think I haven't done that one. Cool. That is C. I might make a mistake on that because I often do, but I think that's right because I've practiced these enough. So that is C. I've taken just over a minute for that, 1 minute 30, which is a pair of functional group isomers. Then cycloalkane, alkene. Just check the carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's A. Easy peasy. Right, what's the total number of structural isomers with the formula? Oh, right. C2, H, Br, Cl, F3. Oh, okay. So you can have C. Well, I've drawn that one. That wasn't a very good start. So I can have all the F's on one and a Cl and a Br on the other. This is a bit more tricky. You can have. I'm going to move an F over. Swap the F and the H. Cl, Br, F. Am I doing this in a stupid way? I don't know. You can have 2 of the F's over. And now I'm swapping with an H and a Cl and an F and a Br. I don't think I've got a good system. You could have. I haven't got a good system here. You could have 2 of the F's over, but have swapped the Br in there. This is not a good system. FFCl. I haven't used a good system here. It's late on Sunday, and I'm not thinking this through very well. That one I've drawn, FFCl. Okay. I'm going to plump for 4, but you didn't see me do that in a particularly good way. Okay, I'm going to plump for 4 of them. I'll have to check the mark scheme in a minute, so I think it's 4. Something tells me, I know I've done it, in a silly way, but I know that's right. That feels right. Anyway, I'll check that. I'll check it now. Yeah, but I didn't do that well. I know I didn't teach that bit well. Right. 4 isomers with the formula. 2-methyl-propan 1-ol. Complete the naming of the isomers in the table above. Longest carbon chain 1, 2, 3. So you're dealing with a propan 1-ol. 2-methyl. 2-methyl position. So there's a propan 1-ol. 2-methyl-propan 1-ol. 1, 2, 3, 4. So you're dealing with a butan. It's butan 2-ol. Okay. Right, complete. Name the type of isomerism shown by these 4 isomers. Well, they've all got 4 carbons in. You got a butan, a propan, a propan and a butane. So you're changing the chain and you're changing the position. So they're mucking around with both chain and position. So I think I would go chain and position. The change in the carbon chain from a but to a probe, and the shift in the ones and the twos is unusual. This chain and position, and I think just for measure I'd put structural. Okay. Question 5. This question concerns the preparation of the plastic poly-2-methyl propanoate perspex. Starts with one propanone. Alright, looks very complicated. Which of the following is not a structural compound of structural isomer compound? M. So M is a carboxylic acid with an alkene 1, 2, 3, 4, C4, 1, 2, 3, 4, 5, 6, H6, O2. Okay. Is not a structural. Should I just go with carbons first? Let's see if anyone's got the wrong number of carbons. God, we've seen some funny looking ones down here. 1, 2, 3, 4. Okay, H6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3. That one. Yeah, that was easy enough. See. See, don't go deep thinking about all isomers. Do that first. Oh, that was skilled. I'm happy with that. I'm happy with myself there. I guarantee you I haven't pre-practiced these. This is me doing the questions for the first time. So hopefully you see how I talk them through with myself. This is not the only way to do chemistry. And I'm sure some chemists might scoff at my approach sometimes and the nonsense that comes out of my mouth. But this is how I do chemistry. Right, octane, identify the homologous series. They are the alkanes. Write an equation to show the complete combustion of. So this was, we've been doing loads of these, haven't we, recently? Anyway, C8H18. C8H18. You put plus O2, you're going to make carbon dioxide and water. You're going to have 8 carbons. You're going to have 9 H2Os, then 16 plus 9, 16 plus 9 is 25, so you're going to need 12 and a half of them. Piece of cake, an isomer of octane. Give the IUPAC name of this isomer. 1, 2, 3, 4, 5. Pentane. I'm scanning there for the functional groups. Pentane, so I'll just 1, 2, 3, 4, 5. I'll just draw a pentane. Now I've got a methyl, a methyl, a methyl, so I'm dealing with tri-methyl. Positions 2, 2, 4, 2, 2, 4. Okay, this works for me. This drawing loops around it. Compound X is produced when an alkane is cracked. Yeah, okay, give that a UPAC name for this. 1, 2, 3, 4. Butene. Position number 1. It's 4 carbons in a row. Forget about that little kink in it with a double bond there. But 1E. You little butene. Next. Doing well here. How many have I got to get through? Flipping heck. How many have I set you? Oh no, they're blank pages. Cool. Alright. Compound X has several isomers. The structure of X is repeated here. A chain isomer of that, so just put 3 in a row instead of 4 in a row and put a methyl in here. Double bond there. No. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. It doesn't ask me for any. Oh, displayed. It does ask me for displayed, so I'd have to draw all of these hydrogens. If you put a CH3 in, you're stuffed. You don't get the mark. Position. Alright, well the double bond's in position 1, so all you've got to draw is butane, put the double bond in position 2. Do it displayed, please. Make sure you do it displayed, all the hydrogens on. This is not displayed, I'm just being quick. You have to put all the hydrogens on. Functional group. Easy, we just done this. Alkene. The functional group isomer of an alkene is a cycloalkane, so 4 carbons. Like that. Boom. You could also do a little ring of 3, I imagine, with a methyl group attached. That also works. You've got a different functional group. And it's same formula. Either. Let's check. Where are you? Yeah, you could have either of them. Boom. Right, the table below shows the structure of 3 isomers with a molecular form of C5H10O. Complete the table by naming isomer 3. It's a ketone, that. 1, 2, 3, 4, 5. Pent. One. Pentan. And you've got to put a number in there. Pentan. 2-one. Pentan 2-one. Yeah, you're doing well here. State the type of functional group isomerism shown. Well, they've all that. This is an ol, this is an al, this is an own. Oh, this is an een, ol. Anyway, different functional groups. Functional group isomerism. There are 7 isomeric carbonyl compounds with a molecular form of C5H10O. Complete the table. 1, 2, 3, 4, 5. Pentan 3-one. Pentan 2-one. They want it done in this way, don't they? CH3. They're after C double bond O. CH2, CH2, CH3. I think they're after that. You can also write this CH3CO, CH2, CH2, CH3, but I'm trying to mimic their way of doing it. Okay, may as well. It's a good plan. 2 other isomeric carbonyl compounds with the molecular formula C4H10O are not shown in the table. One is an aldehyde and one is a ketone. Right, so they've got an aldehyde here, 2-methyl-butanol, and they've got pentanol up there. So they've already got them. You could probably have a propanol. Oh no, you've got that 2-dimethyl propanol. Can't really have an ethane. You could have 3-methyl. You could have that methyl group on here. 3-methyl-butanol. I hope that's right. A part 2. Yes. Yeah, you can. That's what they're after. Draw the structure of each. So I'm going for the 3-methyl-butanol. Butanol is 4 carbons in a row. I think that's quite a hard question, though. That got me thinking at least. They use CH3s, so I'm going to use CH3s. Is that what they're asking for in the exam? CH2. Yeah, that's fine. Isomeric ketone. So what have they done? They've got pentan 3-one, pentan 2-one. Well, they could have like a butan. You could have a butanone. I don't think they've got any butanones on there. Yeah, a butanone. We need to put a methyl on it somewhere. Like that. If I put it on the end one, that'll just be pentanone again, so it's got to be that. Yeah, that'll do. Boom, boom. 3, 4 marks for that. Oh, for all of that. I don't know how many marks I've got, but I've only been going 14 minutes. I feel like I'm flying through these. But you know what? These will have taken you longer. Because it's quite hard what I'm doing. I'm quite proud of myself. I think I'm doing alright. Octane is the 8th member of the alkane homologous series. State 2 characteristics of a homologous series. Oh, there were 5 of them, weren't they? Differ by CH2 as they increase in size. Chemically similar or chemically similar chemical properties. Same functional group. Same general formula. Trend in physical properties, any of them, blah blah blah. Name a process used to separate octane from a mixture containing several different alkanes. Fractional distillation. The structure shown below is one of several structural isomers of octane. Give the meaning of the term structural isomerism. Same molecular formula, different structure. Same molecular formula, different structure, or different structural formula would be fine. I'll try a little look. What we're doing now. Suggest why the branch chain isomer. Name the isomer and state empirical formula. Longest chain 1, 2, 3, 4, 5, 6. Hex. It's a hexane with a methyl and a methyl. 2, 4 dimethyl hexane. Just checking the answer. Cool, yeah. 2, 4. State its empirical formula. So it is C 1, 2, 3, 4, 5, 6, 7, 8. C8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. C8H18. So its empirical formula. C4H9. Can't simplify that anymore. C4H9. Suggest why the branch chain isomer shown above has a lower boiling point than octane. Right, branch chain isomer has less surface contact with neighbours, therefore weaker van der Waals. Like revision in it, because we did that a couple of lessons ago. Less surface contact with neighbours. Compound X is shown below. It's a member of a homologous series. Deduce the general formula of the homologous series. It's an alkene. There are several isomers of X. Give the IUPAC name of the position isomer of X. Well, there's X. That is X is but2-ene, so the position isomer would be but1-ene. Draw the structure of the functional group isomer. Functional group isomer of an alkene. I think you got to draw it properly though. C. Sound like a Spanish man. C. State the meaning of the term structural isomers. Done that before. Give the IUPAC name of the position isomer of but1-ene, but2-ene. Give the IUPAC name of the chain isomer of but1-ene. So you've got to change the chain. So let's put 3 in a row and a methyl there. Methyl propene. You don't need to say 1. You don't need to say 2 methyl because if it was on the end it would be butyl. And you don't need to say 1-ene because there's only 2 places it can go. So it's just methyl pentene. No, methyl propene. Angry man. Right, draw the displayed formula of a functional group isomer of but1-ene. Functional group isomer of an ene. Displayed. Just done this. It's very similar to the last question. Displayed means you display all of the bonds like a peacock displaying its feathers. You need to show everything. That means you're not allowed to write OH ever. You have to write OH. You're not allowed to write CH3. You have to write CH3, etc., etc. Deduce the number of structural isomers with a molecular formula C6H14. So this is my nemesis. C6H14. Alright, 6. 5 with a methyl. 5 with a methyl. Okay, there's my 5s. 4 with 2 methyls. 4 with 2 methyls. I'm stopping at 5 because I think we did this in the class. Do you know, if I muck this up, you've seen me muck them up before, so I'm not going to be that upset. I would take more time in the exam, but I just don't like them. I know they're sort of easy, but I just feel like, you get that number wrong and you're done, aren't you? 5, yay. Let's have a look. State one type of structural isomerism shown by the isomers. One type of structural isomerism chain or position. You can have either, can't you? Can you? State one type of structural isomerism shown by the isomers. Well, that's chain. And these two, its position. It says ignore position isomerism. Don't ignore position isomerism. It must be an old paper. You can have chain or position. Right. I don't know what all these marks are for. I think that must have been where I deleted questions. A different chlorinated compound is shown below. Name this compound and state its empirical formula. 1, 2, 3, 4 carbon. 1, 2, 3, 4, 5 carbons. There's the longest chain. I always do this. Got a methyl and it's got chloros. So you're dealing with a butane. That's a butane, that. And you're dealing with a dichloro and a methyl. Alphabetical. Dichloro. Methyl. Numbers 2, 2, 3. 2, 2 dichloro. 3 methyl. Or is it... Yeah, it's 2, 2 dichloro. 2, 2 dichloro. 3 methyl butane. That is 12E. Where's the answer to that? 2, 2 dichloro. 3 methyl... what am I doing? I dropped a mark. I'm not really crying. Just happens, doesn't it, when you're rushing? Sad face. I know, it's just like looking in a mirror. Right. I was talking too fast and not thinking enough. How many isomers have the molecular formula C5H12? Here we go again. I'm going to try skeletal. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We can get 1, 2, 3, 4 with a 5. 1, 2, 3. 1, 2, 3, 4, 5. Gosh it. 3. I think drawing them out with C's would have been easier. The structure of cyclohexene is shown below. What is the general formula of a cyclic alkene such as cyclohexane? Well, a cycloalkane would be CnH2n because it's just like an alkene. Every time you put a double bond in, it removes a couple of... It's that. How many structural isomers are there with the molecular formula C3H6BrCl? C3. So you've got a Br and a Cl. Br, Cl, 1, 2, 3, 4, both in the middle, 5, 15, 5. Yes. Again, a risky strategy. Avgas is an aviation fuel used in the internal combustion engine of helicopters. I wonder if that's actually true. Somebody Google that. Avgas. Interesting, that, isn't it? I love it when they put stuff on that. I do often think, is that true? You know what? I've got my laptop under here. Avgas. I'm going to do it. Bear with me. I know this is wasting your time, but I do need to know this. Are they just having us on? Avgas. Avgas price. Avgas is an aviation fuel used in aircraft. Yep. Cool. There we go. It consists of a large number of hydrocarbons. In other words, it's still a mixture, including a high proportion of hexane, which can exist as several isomers. Do you know the skeletal formula of 2 branched isomers of hexane? There's 5. There's 2 branched isomers. God, that's a doddle, innit? Or you could have 4 in a row. We could have 4 in a row. There's 4 of them. Anyway, I needed to do 2, so choose a couple. State the type of isomerism shown by... Well, the type... It depends what your answer is. If I drew these 2, it's position. If I drew these 2, it's position. If I draw this one and this one, it's chain. Yeah, chain and position maybe. That was easier, and I draw 2 of them and just do position. Right, dodecane is a hydrocarbon found in naphtha, blah blah blah. Name the homologous series of C2 alkenes, functional group isomer, C4H8. You just have to draw that again. Identify compound X. Okay, C12, 4, 5, 6, 7, 8, 9. So it's going to be C6, 26. So you got 8, 9, 10, 11, 12. C6, A14, alkene, alkene, alkane. Is identifying it just by its formula all right? I think I'd name it as well, hexane. What question am I on? 17. Yeah, you could. Yeah, well, they wanted that, but you could get. You said it. You would allow the name. This question is about isomerism. What a surprise! How many isomers are there? C5H12. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3. Chain. Changing the chain, aren't you? Changing the chain. 5, 4, 3. Yes! Done it. 25 minutes. I think that's happy face now. Although I'm still a little bit sad. That's a sad face about the one mistake that I made. Especially when I said it had 5 carbons and then wrote bute. Happy Monday, everybody. So, do your work, mark your work.